Hello again. Thanks for watching this video and studying your math with me. By now you should have taken the Fake Chapter 2 quiz, and we will go over the solutions here in this video. The solutions also are in your course collateral on Blackboard, so you may also look at them there. This was problem 1. It's the square root curve. It's shifted left 3 and down 4. We have this, and we can have a graph that looks like that and fill out these values for the entries in the table. Number 2 is an absolute value curve. That means it's going to be a V, but the minus sign makes it an inverted V. We can find out the vertex by inspection, really. It is shifted right 2 and up 5 from our reference curve, and we fill out and get these values for the table entry. This graph is a quadratic equation. It's a parabola and it opens down. We can use the vertex formula to find the coordinates of the vertex, and these are the other values we get for the table entries. This is a projectile motion problem, and that's a common problem that I will ask on exams because it tests many things. So we have an equation h of t that tells us the characteristics, and here I've graphed h being over here and t is running along here like the x. Okay, so to find the height of the projectile 2 sections after it's launched, you just plug 2 into the equation. To find out when it hits the ground, you set the equation equal to 0, that's the ground level, and solve. You have to use the quadratic formula, and since time is always positive, you can only use the plus symbol. We ask, when does the projectile reach its maximum height? That really is the vertex formula, because it reaches its maximum height at the vertex. So the time of the maximum height is 7 over 2, and you will plug that into the h to find the actual height. 5 through 8 are here. We solve this one using the square root property. Here we use the fact that the absolute value of this side is equal to the absolute value of the other side. That means either the thing inside the absolute value is equal to the other side, or the negative of what is there is equal to the other side. So I solve those in turn. Here I get x is 5 over 12, or x is 19 over 6. Here we have the absolute value of something is less than 3. That means that the something is caught in between minus 3 and 3. So we solve it, and we are careful to remember that when we divide by a negative, it changes the sense of the inequality. There's the graph, and here is the answer listed in interval notation. This is a different kind of problem. Here the absolute value of something is bigger than or equal to a positive number. That means that what's inside the absolute value is bigger than or equal to 4, or it is less than or equal to minus 4. We solve each of those and we get different solutions. At the end we have an or, so it is 2 over 5 to infinity. The 2 over 5 is included, and it's minus infinity going up to minus 6 over 5, and it is the union of the two. Number 9 is a piecewise continuous function. There is a point of discontinuity happening at 5. So we end up with 2 x-intercepts, 1 y-intercept, and it's useful to note that this function never really gets to minus 5/2, but it gets very close to. That's why this is an open interval. Those are your answers. Number 10 is just the quadratic formula, but before applying the quadratic formula, we have to move the 9 to the other side, and we get these two answers. Number 11 was a circle, and we divide all the way through by 3, first of all, to make the coefficients 1. Then we complete the square on the x and complete the square on the y and add the appropriate numbers to the other side. So the equation is x minus 3/2 whole squared plus y plus 1 whole squared is equal to 13 over 4. The radius is the square root of that. That means the diameter is the square root of 13. Now, to find the domains in range, you have to go to the center and say, oh, I go from the center to the radius this way direction, and I go from the center and the radius this way. That gives me the domain. Similarly, for the y's, I go from the y coordinate of the center to the top and bottom of the circle. That's where I get all of those numbers.